Hey listeners, today we had on Michael McGee, a software engineer working on Firedancer. Firedancer is a new validator client, or basically a second version of Solana's software that's being built from scratch by Chicago-based trading firm Jump. It's meant to make Solana much faster, and even though we've had multiple episodes just dedicated to this thing, we're yet to have anyone from Firedancer come on Lightspeed. So I was very excited to talk with Michael about the roadmap and challenges surrounding Firedancer, as well as his thoughts on Solana in general. I'm very excited for you all to get to hear this one. Let's get into it. This episode is brought to you by Katana, a DeFi-first chain built for deep liquidity and high yield. You'll be hearing more from them later in the show. Nothing said on Lightspeed is a recommendation to buy or sell any investments or products. This podcast is for informational purposes only, and the views expressed by anyone on the show are solely their opinions, not financial advice or necessarily the views of Blockworks. Our hosts, guests, and the Blockworks team may hold positions in the company's funds or projects discussed. Hello and welcome back to another episode of Lightspeed. I'm your host, Jack Hubenek, joined today by Michael McGee, a software engineer working on Firedancer, a new Solana validator client. Michael, thanks for coming on the show.
Hey, thanks for having me, Jack.
So, Firedancer is talked about a lot in the Solana world in almost quasi-religious terms sometimes. When Firedancer comes, all our problems are going to go away. It's this very high-performance client being developed by Jump, I think since 2022, so a number of years now. Maybe, Michael, since I don't know if we've had someone, certainly in the past year, from Firedancer on the show, just catch us up on the Firedancer roadmap. To my understanding, a kind of hybrid version called Frankendancer is live. Full Firedancer is live, but in non-voting mode. Where are we on the Firedancer roadmap, and what can folks look for coming down the line?
Yeah, so there's two parts to the Firedancer project, really. There's Frankendancer, which is shipped, it's live, it's got about 10% of stake. That we first shipped the initial version probably more than a year ago and kind of been slowly acquiring stake, in a pretty cautious way. The full Firedancer hasn't shipped yet. Yeah, it's kind of live and not live here and there in voting, non-voting mode. The state of full Firedancer is interesting. I mean, we've spent 3 years mostly trying to solve one problem there, which is what we call conformance internally. This is the problem of the validators have to agree. So Solana is a pretty complex protocol, a lot of moving pieces. A lot of parts of the protocol, you have to be bit for bit identical, right? If they're computing a leader schedule to determine who the leader is and who gets to produce a block at a certain time, we have to produce the exact same version of it. Otherwise, we're going to disagree and the network might halt. So there's this really kind of big problem, which is you have this huge code base and we're trying to do a rewrite, but we have to get it to match perfectly. So that we've basically been spending 3 years on. And when you look at what we've shipped, Frankendancer, that's kind of been a very small part of our work. Frankendancer, we've had probably 3 or 4 of the engineering team is 20 engineers, really like 3 or 4 people working on that. And that's most of the stuff that we've shipped. So really the big chunk of the team has been working on this conformance problem. The good news with that one is we're kind of getting, a bit of light at the end of the tunnel on that. It's proven to be a bit harder than we thought, but we've, built entire suites of tooling. We have a huge set of what we call test vectors that are things that are testing that the two systems are the same and that they stay the same. And so as we're kind of nearing the finish line on this conformance problem, we can start thinking about, okay, how do we, take this system that we've built and replicated and now put it into a running validator and get all the production pieces finalized, which is kind of the work we've just started to do maybe 3 or 4 months ago. So, we're kind of continuing in parallel these two efforts on conformance to really make sure that we're not going to destabilize the network, and then to actually finalize the last pieces of the full Firedancer validator. The Frankendancer has been going really well. We shipped that, I would say, initial versions 1.5 years ago. As anyone that builds software knows, the first thing you ship, you should, have some problems and ship early. And so we had a few problems. We've been rapidly iterating on Frankendancer and making it better. we track a lot of data about Frankendancer and how it's performing in the wild. And, we see like currently, we're comparable, if not better than Agave on pretty much all of the metrics that we look at. So Frankendancer, I think, is going really, really well.
Mm-hmm. And to define a few terms, maybe for those who are unfamiliar, so Frankendancer, as you alluded to, it's like a Frankenstein's monster of Firedancer, where there's parts that are the original Solana Labs code, and then parts that have been augmented or kind of cleaned up by the Firedancer team. And then Agave is the original Solana Labs client. It was developed, in 2020 or whatever. It has always had some issues, and so and also it is the only true validator client for Solana, which creates some risks for the network with liveness, where if the Solana Labs client or the Jito Solana client, which is very similar, goes down, there's like a liveness risk. So if you have Firedancer also live, it cleans up some of the risks. You spoke, Michael, about this conformance problem and how it proved to be more difficult than you had initially imagined. Can you explain kind of why that is?
Yeah, I think there's a few reasons for that. One of the biggest probably things that we didn't fully anticipate is like how rapidly the Solana ecosystem moves. The Anza team, to their credit, I mean, these guys ship a lot, right? And we don't want to get in the way of any of that. We want to support it. And so we're trying to conform to what is a moving target. It's not like, we decided at some point in time, let's write a new validator client, and here is this specification. I think people always point to like Bitcoin or Ethereum and say, well, these guys have 7 clients and you can write a new one in a weekend. Bitcoin, it hasn't changed since it was developed, right? You can go and write a Bitcoin miner very quickly and send some blocks out. Solana, it's a huge ecosystem with a ton of stakeholders, with a constantly iterating code base, with new features coming online week by week. There is a feature activation schedule where every 2 days Solana has an epoch. And, at the start of an epoch is when you can turn on a new feature. And there's an entire queue of features, right, in a schedule that they've made, because there's so much new stuff coming online. Like every 2 days, it's kind of like, what's going to get activated next? What's going to get activated next? And so we're not just building a system that's static. We're trying to like build to this moving target. Sometimes we spend a lot of effort building pieces of it that then end up getting thrown away. So we've invested, a lot of engineering effort in things that will never see the light of day because they were phased out of Solana or they're being replaced by something better. At the same time, if we try and skate to where the puck is going, let's say, right, like where we think the ecosystem is going to be by the time we would ship Firedancer, we would also never actually ship because we'd be building towards a future that may not come to be, right? We would build some features that are like suspected to be shipped, but then they end up getting canceled or the design changes. And meanwhile, we're not able to run against the current validator mainnet because we haven't built for the thing that actually exists right now. So that's probably the biggest challenge in conformance. The other part of it is there is no specification. So Solana has a white paper, it's like 4 or 5 pages, but then there's some, hundreds of thousands of, haven't checked recently, maybe millions now of lines of code that are the real specification of how this thing works. And it's not like you can go on and understand this very easily, or that there's like a ton of like high quality documentation around it. For some parts there are, but other parts, the code is the documentation, and it's 8 layers of code where you get down and you're trying to figure out, why is our system disagreeing on this one tiny little point? Oh, it's because their code like relies on this undocumented, feature of Rust where like it rounds in a certain way when you multiply 2 right? So as part of our conformance effort, we have to replicate like some parts of like the Rust language in C, right? Like how does Rust do saturating, floating point operations, things like this. So we're kind of been a little bit trying to create a specification as we go. That was one of the goals we set out to do with Firedancer, was to more formally specify some parts of Solana. And we've taken a stab at pieces of it, but it's such a huge system. There's so many moving pieces that it just is difficult. I mean, you just end up having to find things as you go.
Thanks to Katana for sponsoring this episode. Looking for the next big chain? Katana isn't yet another new general purpose blockchain. It's purpose-built for DeFi users and focused on giving the best experience possible. It does this by sustainably generating deep liquidity and high yield. If your assets are sitting idle, they're dead. Katana is built from the ground up with DeFi mechanics to bring your bags back to life. All you have to do is bridge over and Katana does the rest of the work for you. Incubated by Polygon Labs and GSR, Katana launches with a notable ecosystem of primitives, assets, and partners, including Morpho, Sushi, Vertex, Lombard, Chainlink, and Yearn. Be early to Katana. Join the pre-deposit campaign before mainnet opens at the end of this month. Deposit funds and open rewards filled with randomized amounts of CAT tokens. There's also a CryptoPunk and other exclusive NFTs hidden for some lucky depositors. Thanks again to Katana. As always, investments in blockchain technology involve risk. Terms and conditions apply. Do your own research. Well, and I would think that Alpenglow throws a huge wrench in this as well, because, I mean, you mentioned you can't go where the puck is headed or whatever, but it seems like that the Anza team is pretty committed to putting out this fundamental, rewiring of how Solana's consensus works, where like you don't have proof of history anymore, which is, I'm sure Firedancer's put a bunch of time into figuring out how to replicate proof of history on its own client or whatever. So that I can see why it's like a weird, you're sort of trying to hit a moving target while you're also on a moving vehicle or something like this. Yeah.
And I mean, Alpenglow is, an amazing piece of technology. It's going to be awesome. Like, we're fully supportive of it. It is a perfect example of something that makes our life very, very difficult. Proof of history, I implemented that personally, right? That took months, and we implemented the best proof of history implementation I think you could write. It's fully pipelined, like multiple cores come into proof of history and get sequenced really, really well. Like we really invested a lot into that, and we're going to have to throw it away. And that's kind of just part of part of life when we're trying to build this validator. Other parts of Alpenglow, like it's replacing this entire Tower BFT consensus algorithm that existed before, right? Which is another way the validators would come to agree that was slightly less formally specified. And we've implemented all of that. And, we've had an engineer, multiple engineers working on that for, years, I want to say. And that's all going to get thrown away. But it's what we've kind of learned, I think, is the more we try and anticipate what's coming and build for the future, the more we get burned, because a lot of things don't end up happening, and it's kind of hard to predict the future. And like Alpenglow certainly will happen, but what is the timeline? Will they run into problems? If we go and rip out all of our Tower BFT code, well, now we won't be able to ship if Alpenglow gets delayed. We've tied our shipping timeline onto something else. So I think kind of everything is an engineering trade-off. We just look at it case by case and kind of say, do we trust that this thing is going to happen so strongly that we're willing to bet the project on it? Or are we willing to do twice as much work? And, we make that trade basically every week.
I would think that multiple concurrent leaders, where you don't just have one validator leader every block, but you have two or multiple, is one of these things that's a future feature that you maybe don't want to focus on as much, because Anza clearly wants to do this and has talked about it at length, but it seems like a very difficult problem to kind of solve. And so that's one of those things I feel like if you built towards it, it would delay shipping of Firedancer as well.
Yeah, I mean, multiple current leaders, like it's trying to solve a good problem, right? Which is that we want to give applications some way to sequence transactions in a block and prevent their user transactions getting reordered. So I want to say, like, fundamentally agree with that there's a problem and that we want to solve it. But yeah, if you look at multiple concurrent leaders, it has a development timeline that's pretty long. Like, it depends on Alpenglow, for example, and then there's been no agreement among stakeholders on what exactly it should look like. And It would presumably need to go to a governance vote in the validator community, and then the whole thing actually needs to get built once everybody even agrees on what it is. That's something that is, we support solving the problem, but it's too far away for us to go and try and plan our development right now around it. I mean, I don't even think the Anza team is doing much development related to that at the moment.
Oh, and I also did want to say, Michael, you have my sympathy for this proof of history implementation.
Yeah.
The world may never appreciate it, but we, the listeners of this pod will know that it existed. So if that's any consolation to you.
Amazing. Thank you.
Let's talk performance for a sec. For a long time, I think when people in the media or whatever would talk about Firedancer, there was this very sticky meme of 1 million transactions per second. That was where Firedancer was going to push Solana. More recently, I did a piece, after Frankendancer's begun this delegation program, which we can talk about in a bit maybe, and there's been a bit more adoption of the client in Solana. Some of the validators I spoke to didn't talk so much in TPS as how full the blocks were being packed. They were noticing that by that metric, Firedancer was outperforming Agave. And you also, I think, gave a talk at Accelerate about sort of how to pack blocks more efficiently. So maybe to just, as a window into this conversation, do you primarily think about performance in terms of TPS or in terms of how full the blocks actually are?
Oh, in TPS, 100%. The goal of the network is, there's different ways you can try and measure what is the network value. You could say, if the network does 1 billion TPS, it's really, really valuable. Probably that's mostly true, but I could build a toy network that does 1 billion TPS, of users sending cat photos back and forth, and there's not really any economic value. So economic value is kind of hard to measure, but it's what is the amount of real stuff that's being transacted on this system? And the best proxy you probably have for that is fees. If you're a capitalist, you want to say what is maximizing fees, right? That's the kind of most value is being created if people are willing to pay the most to use it. So you want to increase kind of fees is, again, the capitalist view. So ultimately, that looks like increasing TPS, right? The more users can get their transactions in, the more they're going to be paying you. Some people want this stuff to go really, really fast. Traders want to come and say, this guy traded this. Let me try trade the other side. The compute units or the block fullness is a bit of a different problem. It's saying that, so the chain is limited on TPS, right? We built 1 million TPS prototype. It's kind of pathfinding to show that it's possible. And saying, hey, here, this is actually possible. We built a validator that can do it on Solana technology. We put a cluster distributed around the world, and we simulated a bunch of transactions, and we did 1 million TPS. You go, okay, well, why doesn't that change the chain at all today? The TPS is the same. There are a lot of problems that aren't solved by that wayfinding, right? There is the entire ecosystem. It's not good if the chain just goes and does 1 million TPS tomorrow, because everybody that's consuming all of that data isn't going to be able to handle it. You have a read layer, right? You have an RPC that gets served to a bunch of companies that take all this data off the chain and index it into their database. And so, this is funny anecdote, Coinbase was struggling when Solana was doing 1,000 TPS. Imagine if it went to 1 million. Coinbase would just be offline for years. Is that useful to Solana? And it's not just the RPC and the data community. Everybody that's building an app needs to understand everything that's going on the chain to say, did the user pay me? Maybe I need to mail their shoes out. It's the Agave software, right? They have to exist, right? They do a bunch of functionality that Firedancer doesn't do, and we probably wouldn't want to do. So Agave also needs to be fast enough to process whatever's happening on the chain. So we go and build 1 million TPS. It's wayfinding. It's saying, hey, here's how you could do this. Everybody kind of can look at it and say, oh yeah, that's a reasonable target. It's possible. Now, how do we engineer the rest of the ecosystem towards it? So while that's happening, there is this compute unit limit that's in place to make sure that everybody can keep up. The Coinbase, the RPCs, Agave, and we're subject to it as well. So the biggest blocks we can produce are 50 million compute units right now. It works out to, in practice on normal size transactions, 1,000 or 2,000 a second. And this is it's annoying for us, right? Because we've gone and built this incredibly fast validator, and we go out and run it on the real network, and okay, it does 1,000 TPS, the same as all the other software. But again, it's because it has to. We can't go and stuff 1 million TPS down everybody's throat. So because we're subject to this constraint, you say, well, what other engineering can we do? Obviously, the best engineering is to just increase the constraint. And everybody in the ecosystem is working, really, really hard towards that goal. We have an amazing performance team at Anza that is working to make the Agave software faster. And we're doing these gradual compute unit raises so that the ecosystem kind of gets boiled slowly, like, the frog in boiling water. Like they're going to kind of be able to sense that there's this change. I guess it's the opposite of the anecdote, but they'll be able to slowly adjust as the temperature increases, rather than like tomorrow, you got to do 1 million TPS, haha, your software's offline for 2 years. So all of that said, we have a compute unit limit. We built this really fast software. Like, what are we supposed to do? We can't go out and yell at everyone, hey, our software is way better, but it doesn't really matter right now. There's kind of two things we can do. One is go out in the ecosystem and try and help the ecosystem improve, which we're doing a little bit of. And, the pathfinding is a huge part of that. It's just showing the way to do this. The second part is we can play within the constraint we have, right? The blocks are limited to a certain size. What can we do? Well, we can just make sure our blocks are always really, really full. We can always make sure that they're totally at the limit. And we can fill them really quickly. Like, we just built a prototype of a scheduler that fills all of the blocks 100% if that many transactions are available in 130 milliseconds. And it's actually on, live on the chain today. So we're kind of just been playing around and saying, what are things we can do while we're working within this constraint, and how can we make the chain more valuable, even though the compute limit is going to increase slowly. So that's kind of the distinction. The TPS is better. We want to improve throughput, but while it's capped and we have this fast technology, we might as well, use it to give some benefit to the operators and the users.
Interesting. The other piece just on TPS is like a commonly cited figure. I don't actually know if this is exactly accurate, but they'll say that like Visa's max TPS is 65,000. And Visa clearly does a pretty good job of processing all the payments that it needs to. So even if you could do 1 million TPS, it's not necessarily clear that you would need to do that many transactions in a second. I mean, maybe there's some like crazy market maker shenanigans going on that would cause that the TPS to spike that high, but it's a nice round number that is kind of meaningless, I would argue, as well.
Yeah, it's kind of. I mean, Visa and MasterCard, yeah, maybe 60, 70,000, something like that. I've heard that number kicked around too. That is, for the most part, retail commerce, right? So if we wanted Solana to be able to replace every point of sale and every, online e-checkout, you would need to do 60, 70,000, which is a really good target to have. But if you go and look at what like volume exchanges are doing, like a stock exchange or a futures exchange or options, they're doing way, way more than that. The net sum of like financial transaction volume is surely in the tens or hundreds of millions a second. So it depends, what are you trying to build for, right? I think if we could do 100,000 TPS, then that chain has already massive, massive utility. If you're trying to replace like all equities markets, then you need to go to 1 million. So there's certainly like different points along that spectrum to build towards.
Yeah, and this is maybe a bit beyond the purview of this conversation, but just like, I don't know if the barrier to why like more of the world's equities markets or something are not trading on blockchain rails is necessarily the TPS question. Like, as we've learned, the past couple of weeks, there's regulatory risk. There's other reasons that like we use the databases we use and not blockchains. But yeah, point taken as well.
Yeah.
So in this talk you gave at Accelerate, you noted that at some point, every problem on this chain ends up being the CU limit. So I just want you to like unpack that a little more. It's something that we've talked about on this pod a few times before, is that, throughout the year, Anza is slowly raising the compute units. I think of that as like Ethereum gas, I guess, that can be included per block.
Yep.
But why? Like, I don't exactly know how to conceptualize why that's important. So explain that to me.
Yeah. Every problem on the chain relates to compute unit limit. I think if you look at the things that people would say are problems with the chain, there's some examples. I mean, multi-concurrent leader, what's it trying to solve? It's trying to solve like leaders reordering blocks to like, create arbitrages that didn't exist maybe, or to, mess with how an app is receiving its transactions. You have sandwiching, you have like interesting types of trades that probably shouldn't be happening. You have leaders like users want fast confirmation, right? That's another problem. They want send their transaction, they want it to be landed and confirmed really quickly. So there's a few different problems, and everybody always has like some novel solution, right? Or to the sequencing problem, let's do like multi-concurrent leaders, which is, a multi-year development roadmap that is kind of like, okay, we change the whole mechanics of the chain, and multiple computers can be leader at the same time, and then everybody has to sort the output of their work and like compare it. And, so you can kind of come up with arbitrary solutions, and you can also kind of just step back, and this is a little bit how I feel about things, and say, well, maybe a lot of these are just performance problems at the heart. And like if someone was receiving 1 million TPS and they were able to include it in their blocks, like, would they really have time to be playing a bunch of games like with users' transactions and like reordering them? And if we're doing 1 million TPS, like one of the things we've seen with our current validator when we're in this compute unit limited environment is that the validator has 400 milliseconds to produce their block. They can often make a more profitable block by delaying execution of transactions. So if you have 400 milliseconds, what you kind of want to do is wait until the end of your block, and then look at, what's the best stuff I received, and pack it in really quickly. But this isn't really particularly good for the network. I mean, you've now just had a 400 millisecond period where you were basically doing nothing. And what the chain is looking like is like each leader does nothing for 390 milliseconds and then does work for 10. And so we've lost a bunch of our capacity, and we've also lost latency, right? Users that send a transaction, well, now it's not getting executed and put in the block until potentially 400 milliseconds later. So if you increase the compute limit, what would start happening to the validators is they say, I can't wait so long because I have a bunch of work to do, and I'm not going to finish it all if I don't start earlier. And so you just raise it and raise it and raise it. You can't really play these kind of games anymore, or it becomes very difficult. And yeah, sure, there might still be some cases where like some transaction's so valuable that the validator wants to try and delay it and shift. But I think on the whole, it becomes less likely. And just to kind of tie it to Firedancer, like our whole thesis with Firedancer is that like blockchains haven't realized their potential yet. That if you could, Bitcoin does, well, I'm not up to date on the numbers, but I think like 7 transactions a second. When we're talking about like Mastercard doing 70,000, Ethereum does like somewhere in the tens, like 70 maybe, and Solana's doing 1,000. What if we could build a chain that does 1 million? Like, what kind of applications could people build? What kind of utility would there be? What would the latency? The latency is super low. The throughput is high. No one has really built this, and so if we can kind of bring that into existence, maybe it'll just solve these other problems too.
That's fascinating, and I'm glad you bring up this this kind of recent problem. I think is what you're referring to of basically just validators processing blocks too slowly, and some like we did a piece recently. Solana Compass is one of these validator behavior raters, and he, whoever runs that has added in the median block time or something for your validator with like other performance questions. And I guess I just wanted to ask, like, when you think about these like timing games or other sorts of games that are played on Solana that are to the detriment of the network or to users, so things like waiting till the end to do a bunch of work in the block or sandwich attacking, is the answer to that just greater performance, or are there other ways you're thinking about how to alleviate some of these? I don't know how to categorize them, but the stuff that validators are doing that are capitalist and advance their own interests, but are bad for the chain or for users.
Yeah. So there's kind of three prongs to it, right? Three ways you can attack these kind of problems. There is, and let's take an example of like people extending their blocks longer than they should. It is a bit of a tragedy of the commons. Like, if I extend my blocks, I might make a little more money, but now the users have to wait longer. It's actually damaging the chain. I'll probably make less money eventually because users may not like Solana so much anymore. I've also, like, if every validator did it, everyone's blocks would be extended, and now we're no better than we were before. So yeah, these are kind of a tragedy of the commons. There's like three approaches, and there's one that's really, really favored by Solana development teams, is to solve it at the protocol level. That's a really good example, that block time one, because it is something that's solved at the protocol level. Alpenglow effectively solves it. The validators vote on how long the block took, and if they kind of agree that it was taking too long, they skip it, and the leader that produced that long block makes no fees. That was kind of what proof of history was supposed to do, but it's has some limitations that don't enable it to do it very well. So this is a really good case where like you can develop a protocol solution and it works effectively. I would say the problem of like sandwiching is a bit different, right? Like, people have been thinking about protocol solutions to this for years and haven't really come upon anything that was very compelling. If there was like a simple protocol change that would prevent that, I think everybody would have been on board and done it. But currently the best thinking, is coming from Max, is like multi-concurrent leaders, which is a huge engineering, amount of engineering work. At the same time, like, sandwiching has been much decreased through other mechanisms, right? There's a social layer, which is, if you're a validator doing sandwiching, people can see that and they can say, well, should we be giving this validator stake? And there's some really good sandwiching site now, I think sandwiching.me, that's been kind of calling people out. So there's a bunch of like social consensus that happens too that can solve problems sometimes, but it's certainly not preferred to doing protocol changes. And I think wherever possible, we're looking for protocol ways to solve problems.
Thanks to Katana for sponsoring this episode. Looking for the next big chain? Katana isn't yet another new general purpose blockchain. It's purpose-built for DeFi users and focused on giving the best experience possible. It does this by sustainably generating deep liquidity and high yield. If your assets are sitting idle, they're dead. Katana is built from the ground up with DeFi mechanics to bring your bags back to life. All you have to do is bridge over, and Katana does the rest of the work for you. Incubated by Polygon Labs and GSR, Katana launches with a notable ecosystem of primitives, assets, and partners, including Morpho, Sushi, Vertex, Lombard, Chainlink, and Yearn. Be early to Katana. Join the pre-deposit campaign before mainnet opens at the end of this month. Deposit funds and open rewards filled with randomized amounts of CAT tokens. There's also a CryptoPunk and other exclusive NFTs hidden for some lucky depositors. Thanks again to Katana. As always, investments in blockchain technology involve risk. Terms and conditions apply. Do your own research. One other piece there is just, I guess, like, where is there the most meat on the bone to improve Solana? So, like, if you drew out a diagram of like the whole, from a user wallet to the blockchain, there's like this whole rigmarole that a transaction has to go through. So in that whole Solana process, like, Where do you find that there's the most room for improvement?
I would say just the performance and the speed right now. I mean, we are still doing 1,000 transactions a second, right? So there's Tolly, I think, has this like sliding scale of pain that he talks about, which is that like user pain is the most important. If a user feels any pain, that's like really, really bad. If a developer feels pain, it's kind of bad. It's not ideal. We really want developers too. And then if a validator operator feels pain, that's, not terrible. Like we should fix it. And then if a core protocol developer feels pain, who cares? And, if maybe like Tolly feels pain, like, people enjoy that.
Yeah.
But so the user pain is the worst, right? And there's a bunch of other problems we can go solving, like operator problems around how to run a validator better, or developer problems like around SDKs and tooling and writing, secure programs. But like the user pain is the most important. And the user pain is like kind of two things. It's like I sent a transaction and it didn't land quickly, and I sent a transaction and got dropped. Like there wasn't enough capacity on the network. So I think there is a lot of excitement here, because it's not like we need to go and do a crazy more amount of deep work. Like the CU increases are coming, and they're coming very rapidly. There's been a bunch of low-hanging fruit. I think Alessandro from Anza likes to say that it's all just bugs. People think these performance problems are like, that they're like foundational engineering challenges, and we need to go re-architect this and build data centers and route dam water into that. And it's like, no, like the software mostly has bugs, and you can fix them and realize like pretty significant performance wins. And yeah, maybe when we get to like 200, 300,000 TPS, we'll have to go do crazy, re-architecting and re-engineering of some of the clients. But no, right now we can get huge wins by just clearing out that debris and taking the easy ones that are there.
But I'm saying like on a micro level, like where are the easy wins? Like where's a lot of the debris? Is it like the fee markets? Is it the way that transactions get propagated throughout the network? Where have you found that there's a lot of improvement that can happen?
Oh, interesting question. Well, so in Frankendancer, we can already probably do a few 100,000 TPS if the compute unit limit was raised. I mean, we've run, we run private clusters that can do far beyond that. So Frankendancer, I think, was an exercise in figuring out a lot of where that debris was. For the most part, it's in the leader pipeline. So you need to be able to pack blocks that are that big, right? If we're the compute unit limit was 300 million, and we need to be doing 10,000 transactions a second. There is a little bit of involved work in, okay, like we need to receive all these transactions well, we need to rank them, we need to put them in the block, we need to execute them quickly. So we took a design there that was largely inspired by Agave, but had a bunch of kind of key changes. And that enabled us, I think, to do really, really well there. So the Agave team is kind of like taking a fresh look at their leader pipeline for the last year. I mean, they've made some really, really good improvements. And so, the scheduler is probably the biggest component of this. If you think about the work a validator has to do when it's leader, it has to do some work that you might think is hard, like verify transactions, right? You have to check that the signature is valid, that the user that's transferring the funds is authorized to do so. This is like a cryptographic operation that's pretty expensive, but it's like scalable, it's parallelizable, so we can run it on many CPU cores of the system. So no matter how many transactions we're receiving, we can just scale up capacity to process it. On the other hand, the problem of scheduling, like deciding what goes into a block, basically has to be done on a single CPU core. Like absent some incredibly novel, like groundbreaking engineering, you pretty much have a list of transactions and they may conflict with each other, right? They're trying to send funds from the same account, for example. So you need a single place that has a view of all of this and like really, really quickly schedules those transactions for execution without trying to send funds from the same account twice. That, I think, was a big bottleneck in Agave. We have a really specialized custom scheduler for Frankendancer that'll be also used in Firedancer that we've put a lot of engineering effort into solving this like single core like performance issue. And it's basically a greedy scheduler, right? It runs through transactions highest value to lowest and just tries to schedule them each in turn. And it turns out if you try and do too much complicated work in there, like figure out what transactions are dependent on which and like do some smart analysis of who can, then you end up just stalling your scheduling. So Agave and Anza realized this also probably a year or two ago, and they've done a lot of engineering work to change their scheduler also to be a greedy scheduler. So that's kind of like some of the work that's, it's not like build data centers and write computer science papers and it's just like, okay, our scheduler is slow. Let's write a new one that, is using a much simpler algorithm.
Isn't Alpenglow going to be, it's doing, it makes changes along these lines as well, or am I misremembering?
Not quite. Alpenglow maybe has one nice benefit. It's currently the case that votes on Solana, so when validators vote on whether a block was valid, are transactions, then they get sent to the leader, and the leader has to put the votes in the block. Alpenglow changes this so that the votes are kind of distributed out of band through a separate system. So in that sense, it maybe is a minor improvement, but
the scheduler thing is a separate consideration.
Yeah.
Gotcha. I want to talk a little bit about modding. There's this kind of, I don't know, environment in Solana where I think one of the difficulties is just things that happen out of protocol that are hard to always observe. So including like modding your validator to have some desired effect. So I'm curious how Firedancer handles that.
Yeah. So we support it. I think, there's like probably two futures with modding, and one of them is good and one of them is bad, right? Like a bad future with modding is that one team writes a big mod that kind of says, oh, we're going to be the team that receives all the order flow and decides how to create blocks, and we're going to win and no one else will be able to compete. And then everybody just runs like one mod. And that's probably not great for Solana long term. There is another future which is much more likely, and probably what will happen here, which is like there's a vibrant ecosystem of mods, and everybody has their mods that they've written and they share, and some people like run this and some people run that, and there's different agreements in the space around what transactions get sent where, and it's like kind of a thriving little ecosystem. I mean, I guess there's a third future where like nobody runs any mods at all, but I don't think that's an eventuality. So we're pretty excited about like this second one where, there's a ton of mods and it's easy for people to write and try new things. I mean, that's how you get, evolution, and like how you let like good ideas surface. And then maybe if they're really good, we bring them into the protocol. So in that sense, I think we're long-term supportive of modding. One of the like initial mods, we wanted to support was Jito. Our goal is to be neutral, right? So we want to support anyone that wants to build anything on top of Firedancer. We want to support them. We want to have standard tools and processes for them. Jito is a cool initial case because they have a lot of adoption in Solana. So we thought, when we were supporting this Jito integration, is like, how do we do this in a way that's really clean? So what we want is for them to kind of be able to run in a little sandbox, right? They can build this block engine integration where essentially we can uphold two properties of the validator that are really important to us, right? Which is the performance. We're still able to do 1 million TPS theoretically, and security, where like there's not a big attack vector or something because of one of these mods. And so we use that as kind of an initial case to say, okay, how do we support this system effectively? And what we found is like with the underlying architecture of Firedancer, it's actually very straightforward. All of Firedancer is built on these kind of primitives we use in the trading space, which are kind of message buses, right? Messages get passed between different parts of the system. And so when you're going to write a mod, you can just subscribe to any messages that are going internally between the system you can send messages, which are transactions. So we found that we're actually able to have a pretty flexible modding infrastructure. And I think in around a year or two, we're going to actually publicize some of it and write a bunch of documentation and have a really, really nicely formally supported way for people to have mods.
Interesting. What about like another kind of alternative arrangement I've heard about is just these like alternative TPU ports, basically.
Yeah.
And this came up a lot around SIMD 96, and basically, like, you don't want these alternative TPU ports to happen as much because you could, I guess, use them for things like sandwich attacking or whatever. And it's just better if stuff in the protocol is observable, is the argument. But what would be your approach to something like that?
So I can speak for myself. I actually have a history in US equity space doing market making there. And US equities is a very interesting example. If you look at how that marketplace is structured, you have clients, which are people like you and me ultimately that are going on Robinhood or Fidelity or Charles Schwab, and we like go to buy Apple. And what happens when you click buy on Apple is your broker, let's say it's Robinhood, sends your order to Citadel effectively. There's a few other market makers, but most of the market share is Citadel. They send it to Citadel, and Citadel runs essentially an order router, they call it. So they pay Robinhood for the privilege of receiving this order, and then they receive the order. They kind of decide one of two things. They're either going to take the other side of it, so they're going to sell you Apple themselves and take a bit of a position, or they're going to pass it on to an exchange or some other counterparty and not take on any risk. And they do this all day and try and capture a little bit of spread. And one thing, people complain about this structure a lot, but it does give retail incredibly attractive prices. They pay no fees. Citadel will often cross the spread for the retail order because they know they're not, trading against like Warren Buffett. They're not going to get adversely selected. So they can give a much better price than the user would if they went to a public exchange. So the parallel with Solana is like people are starting to kind of say, okay, maybe we should have some type of order routers, or maybe flow should get directed in certain ways, but no one is really sure yet. There isn't a lot of infrastructure. No one's particularly good at it. No one's really sure what this would look like. I personally think it would probably be good if when a user wants to buy a token or a stock or something, if they go to the lit public market, which is basically the order book on the chain, they're not going to get a very good price. That order book has to account for the fact that Warren Buffett might be the guy coming in to take the bid or the ask. So if you're you or me trying to buy some Apple, probably it's good if we have someone we can send it to that says, oh, I know this guy Michael is not a very good trader. I'm just going to give him some Apple at a good price. And that is the whole thing that I think people are trying to flirt with building, right? When they talk about custom private TPUs, it's like, okay, I want to send it here so I can get a good price. And they trust that I'm not going to send them bad stuff. But so I'm kind of for it. I think, again, if we can create a healthy, diverse ecosystem of flow going in certain places and people figuring out what flow is good and what is bad and giving the good flow from the users really good prices, that's ultimately going to be better for the chain than telling users to go hit some public order book where they got to cross a huge spread.
Mm-hmm. Yeah, and you're starting to see things like this emerge, I guess, in we call them proprietary AMMs, where some people with a deep understanding of Solana market structure will kind of run their own market maker and quote better prices than anyone else. And so a large amount of Jupiter's Solana USD swap flow runs through SolFi, which is run by Ellipsis Labs at this point. I guess my understanding of what separates payment for order flow from private TPU ports in Solana is that Citadel can't go and front run and then back run your transaction because they'd get in a lot of legal trouble. But random alternative TPU port in crypto might do that, and that's bad for users.
Yes and no. I mean, yes, the regulators are heavily involved and they prevent certain things, but it's a repeated game, right? If Citadel will like repeatedly front running user transactions, eventually the brokers like Robinhood, they're going to notice and they're going to stop sending their flow there.
Mm-hmm.
And that's really bad for Citadel because they need that flow for their business, and the flow is valuable enough on its own. So I think it's enough of a repeated game that as people build reputations and the counterparties kind of like come to know one another, that it becomes a bit less of a problem. I mean, already you have places you can send orders where you're like, they're probably not going to sandwich you, right? I would give the example on Ethereum. There's this slipstream where, if you want to get a transaction in without anybody seeing it or front running it or observing it in the mempool, you can send it to a certain validator and they'll like promise to. And I don't think even if they got a really, really juicy transaction, they're going to like deviate from the course, because then all of their future business is shot. So it is, I think, probably possible to build this kind of credibility system in the repeated game we're playing enough to have effective prevention of these, kind of bad trades that you talk about. I would also say, like, people complain, about the payment for order flow and but like the U.S. equities market is probably the crown jewel of the trading world, right? It's amazingly efficient, zero fee. Like the spreads are incredibly, incredibly narrow. If Solana can compete or do better with that marketplace, we're winning. Like that would be very good.
Yeah. Okay. Well put. As far as one piece, I guess I wanted to touch on with the Frankendancer client is I think one of the newsier items that I've been watching the past couple months is just the amount, the percent of like stake that's running on Frankendancer, because you built this whole validator. It's really performant. It packs blocks well, whatever, but it may still be difficult to convince validators who have always run on this one client to go, run their validator on this other client. And I don't run validators, so I don't really like whatever considerations there are. There's some kind of cost to doing that to you. Firedancer has rolled out a stake delegation program where some validators, similar to how the Solana Foundation will delegate stake to kind of bootstrap smaller validators, Firedancer is doing something similar. But I'm just curious to hear about that whole project, what the thinking is there, and just more broadly, like how you guys are trying to actually get validators to use this thing once it's built.
Yeah. So adoption is hard, right? Anybody that's probably built a business or a startup knows it's not enough to build something that's equally as good as what's already there. If you're trying to build a competitor to something that's in the marketplace, you have to do much better. Has to be a step change for people to switch. So we kind of relearning that lesson, I think, with Frankendancer is we need a really, really compelling reason for operators to switch. Now, you might say, oh, well, shouldn't it be faster, right? The performance is much, much better. And we kind of talked about that a lot earlier, which is, well, yeah, but the compute unit limit is kind of capped, and it'll always be capped at a speed that Agave can keep up with. Right. Otherwise, again, the network is going to fail to function. So it's unclear if we'll be able to get a durable performance advantage, or if we're just kind of doing this wayfinding job, right? And saying, hey, here's how to be fast. Now everybody go and make yourselves fast too. So with that in mind, you say, okay, well, how could we get stake, right? Everybody's been running this for years. It's their livelihood. These people run, this as their business. We need to give them something compelling. And so even a year or two ago, I think we started thinking about this, and a lot of the work you've seen come out of the team has been a result of that. We're trying to be incredibly operator friendly, like even from some of the sillier things, like we have a configuration file. It's incredibly well documented. The validator operators can go and read it and understand all the options that are available to them very, very easily. We have a really standardized metric system, which means if a validator wants to monitor how well their validator is doing in production, we have standardized tooling, and it spits out a page that gives them an exact report. So that's silly stuff. But then we kind of take it a step further and said, okay, well, like novel things can we offer the validators if we can't, produce bigger blocks? What can we do that would get them to switch? And the GUI is a really good example of something that came out of that. Like we kind of conceptualized. I don't think anyone in the space has done this. Built a visualization and front end software for a validator, but we went and did it. It's been an ongoing labor of love, and I think the validators really, really like that. It's kind of a huge asset to running Frankendancer and soon Firedancer. So we've kind of been doing a bunch of different stuff. I mean, we kind of go above and beyond for the validators. We'll like monitor their performance for them if they're running Frankendancer and like reach out and say, hey, we think you have this misconfigured, or check this option, or maybe you need a bigger, more RAM. So we're really like trying really, really hard to get that adoption. At the same time, we want to be careful, right? The more adoption you gain, the more like integral we are to the network, and the more risk there is when things go wrong. And the 20% threshold is the really important one to watch, where with the current consensus, if we got above 20% stake, some outage in Frankendancer could bring down the network. So that's kind of a lot of the background. So even though we are trying to get stake, we're also like being careful and trying to do it slowly. Now, the stake program is kind of, the delegation program is kind of a result of a lot of those efforts, and like thinking, okay, how do we get people that, there's a bunch of costs surrounding Frankendancer that may be unappreciated. Like the validators have bought their hardware specifically for Agave. We may, require slightly different hardware. They've like tuned their operations and invested a bunch of time and energy into this. And so we want to also say, okay, like maybe they need a little bit of a help just to get started on that switch. So that's kind of just the delegation program, is there just to like give a small incentive and a bit of encouragement for people that are kind of close to making the switch to saying, okay, let me try and run it. And we do need people to run Firedancer. I mean, we want the virtuous cycle, right, of feedback from the community coming back into the development team and driving our future development. We need to make sure this thing is stable. The whole point of the two validator split, right? We had Frankendancer and we had Firedancer, is we're trying to rebuild this huge code base. If we went and just did it in a vacuum and like off in a basement drinking Diet Coke and came back 3 years later, like we would never actually ship anything. The project would not succeed. We need to have something that we can ship early and ship repeatedly, right, to start getting this community feedback. And so that was kind of the point of Frankendancer, and having it get stake makes it much, much more effective.
And so you said that 20% is the threshold where Firedancer could present a risk to Solana. But what is, like, on the flip side of that, say Firedancer is like full Firedancer is ready to go, voting mode, whatever. What percentage adoption do you need to see for it to actually protect Solana from liveness risks with the Agave client?
So this is an interesting topic. There's two kind of risks to the network from liveness, I would say. There's one that's really, really, really bad, which is that someone found a bug in Agave that lets them do an infinite mint, as an example. So someone finds a bug in Agave that lets them create an infinite amount of Sol. And what they're going to do, if that happens, is they're just going to bridge it all out of Solana immediately. The price of Solana will go to zero, and they'll probably have got, some hundreds of millions or billions of dollars out by bridging, and then the chain is dead. And everybody's out of a job, and the users will go, So that's a nightmare scenario, right? Infinite mint. There's a couple other things that would cause that too, but like a loss of funds, I guess, if they can forge a signature. So that is the really, really bad case that we really, really, really want to prevent. And Firedancer helps prevent it. The reason is that we would have to have the same bug for an infinite mint to happen, right? So if someone finds a bug and they execute it, and the whole validator community is running Agave, they'll all have the same bug. And so they'll all replay this transaction that's giving this person an infinite amount of Sol. And they'll say, oh, yeah, that looks good to me, because they're running the same bug. And then the bridging happens, and everybody's jobs are gone. But if there's 20% or more of Firedancers, hopefully when we went and recreated Agave, bit for bit, bug for bug with this painstaking 3-year effort, we didn't recreate the security bug, and we were a little bit independent enough to not do that. And when it runs on the Firedancer clients, they'll disagree. They'll say, hey, wait a minute, this person isn't authorized to create all this SOL or whatever. And what will happen then is the network will halt. So because there's a disagreement and less than 80% of stake is able to vote on the same block, the network will stop producing blocks and everything will halt. And that kind of sounds bad. Well, it goes offline. Like, that's not good for users either, but it is much, 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 much better than, all the funds getting bridged out and the chain collapsing. So that is the good case that Firedancer helps, actually. And the more clients you have, the better protected you are in that case. The more clients that are above 20%, the more likely it is that the bug doesn't exist in all of them and the chain will halt rather than collapsing. So that is the good case. The not so good case is probably a bit more common, and this is where it's not an attacker trying to steal funds. It's not some infinite mint. It's just like a routine bug in in some part of the Solana blockchain, right? I give an example, like let's say, I don't know, the stake program or the vote program, and let's say the way you compute the timestamp of a block is when all of the network votes on the block, they put their timestamp on their vote. And then the network calculates an official block timestamp, which is based on all of these votes. It's kind of the stake-weighted median. This timestamp is actually part of consensus for interesting reasons, but so everybody has to agree on this timestamp. It doesn't really matter. It goes out to RPCs, it's used in some other ways, but it's included in the hashes and things like. So what if we got a timestamp wrong, right? We rounded some calculation wrong and we're off by a nanosecond. It ultimately, if it was just Agave that was wrong, it wouldn't matter. The whole network would see a vote timestamp was off by a nanosecond and proceed and not care because it doesn't matter. And that's probably the routine case. With Firedancer, if we disagree on this vote timestamp, now the two softwares are disagreeing, and so it's the same as if some huge amount of funds is being bridged out. The chain is going to halt, and that is, it's, you can argue if it's good or bad, but it's probably not great for users. If right, there are small bugs that maybe wouldn't have affected them. Actually, having multiple clients makes the chain kind of down more than it would without. This is true until you have 3 or 4 clients with evenly spread stake, where then if one of them disagrees, that client just goes offline and the others all stay online. But while there are clients above, while there are 2 or 3 clients, probably a failure in any one of them can bring down the chain. So we're kind of very aware of this, and that's part of what I mentioned with the multi-year effort is we really, really want to prevent this. We want an incredible amount of tooling to check everything, to make sure that there's, very, very little chance that anything can go wrong. We also want to make sure that if something does go wrong, we can come back up incredibly quickly. So if things go wrong, maybe we take all the Firedancers offline really briefly and have a process to realign them with the Agaves and spin them back up in a matter of minutes, right? Maybe we design mechanisms where the Agaves keep running, or there are kind of ways to approach this where you mitigate the harm, but it's definitely, a big engineering challenge. And I think not well understood, these two types of difference and the value of catching either of them.
Yeah, that's interesting nuance that I don't think I hear much about. Also, just on specific questions, I guess you've referenced at various points that raising the block limit would really help Firedancer boost Solana's TPS. Anza has said that in 2025, I believe it wants to double block space, so that would be from 48 million CUs to 96 million. Is 96 million good in your eyes? Or if you could set a number where Michael could wave his magic wand and that's the new block limit for Solana, where would you put it?
I would remove it.
Unlimited. Okay.
Yeah, the interesting thing with Solana is the protocol is kind of designed to allow the leaders flexibility to produce what they want. So what I mean by that is, let's say I'm producing a block and I stuff way too many transactions in it and it's too big and no one can replay it. What should happen is the network should skip my block, right? Let's say it takes a minute to replay my block. Well, I only have 400 milliseconds. So if I produce this block and everybody's chugging away, take 10 seconds, 20 seconds, 30, trying to replay what I've produced, they should just time out after like 400 or 450 milliseconds and say, oh, that block was too expensive, and throw it away. So in my mind, like having this kind of system where the block leader is responsible for producing a block that they think the network can handle and kind of like going up to that limit is really good, because it encourages, like, it doesn't encode a bunch of rules into the protocol. It doesn't require like a development team constantly going and like, saying, oh, do we think the network could do this? And right, it's like we just empirically would observe in production. The validators will slowly edge their blocks up towards the line where they're getting accepted and then keep it there. And as the hardware improves of the network, the validator operators will naturally like improve their scheduling and make their blocks slightly bigger. It has a cool effect of it pushes the network forward. It means like if you're one of the 10% of slowest validators, you're maybe not going to be able to play some of the blocks that are getting produced and you're going to fall behind. And then you're basically forced to upgrade your hardware. So it embeds in the protocol this need to like everybody to constantly be upgrading and making the network faster together. Whereas today, like you can go buy like some really, really slow hardware because it can do 48 million. And then if someone tries to raise the C limit, say, oh, this is bad. Like I can't replay this, right? And then the development team has to think about, okay, well, there's other problems with the compute unit model, which is it's very hard to actually, what you're trying to model with that is how long a block takes to replay. But it's kind of like Ethereum gas, right? It's based on this notion of like code instructions being run on the validator. And sometimes those two are very detached. Like how many code instructions you run is not very well related to how long the block actually takes to replay. And so the development team is kind of going to end up in this place where you're constantly trying to readjust your model. It's actually already kind of a sophisticated model to say, oh, how do we, maybe people switch, there's some new kind of RAM that's way faster or way slower or whatever. And now the cost of like accessing account data went up or down. And so our model has that completely wrong, and blocks that we thought should be fast are actually slow. So it's just a lot of work and it's a lot of complexity, and you can kind of just sidestep the whole thing. One of the big, I think, annoyances with Firedancer is if we've built a really good software, we want to be able to differentiate it, right? We want to be able to come in and say, hey, we're much better at this, or we're much better at that. Or at least maybe we're not better, right? Maybe the existing software is better, but we want to have a space where we can compete. And a little bit, the chain right now doesn't have great places for people to compete. The compute unit limit eliminates any competition on blocks. You have 400 milliseconds to vote, 2 on every block. So pretty much everybody can vote on every block in a timely fashion. And those are the two things that really determine your rewards, is how well you vote and how well you produce blocks. And so there is no driver of competition there. There is nothing, encouraging development teams to go and build a really, really good system for these, because, it's not going to translate economically. And the same is true of the validator operators. They're not fully incentivized today to buy better hardware and move the network forward productively.
Yeah, that's really interesting. It's just sort of creating more of a market force, I guess, around how much you can even pack these blocks.
Mm-hmm.
I also want to ask, so say we did this, say the compute limit was removed, and now all of a sudden Firedancer is very fast and Agave is maybe less fast. How does that actually show up in the blockchain? Like in your user experience, does Solana become like an average of the two clients or something? Or like, does it only run as fast as Agave runs?
It runs as fast as the slowest 20% of stake, right? Mm-hmm. So 80% of the network needs to agree to have the network keep making progress. So if I'm producing a block and I produce a block that only 50% of stake can replay in 400 milliseconds, then my block is going to get skipped and I did a bad job. So what every leader will end up targeting is, at that 90%, probably 95% rate, which is good. That's what's churning the bottom 5% all the time and kind of getting them to upgrade their hardware. But so it would be whatever the 80% stake cutoff is. I mean, do you think there's a future where Agave has less than 20% stake? I don't really see that. So I think as long as Agave has more than 20% stake, which is an almost certainty, then it'll be the slower of the two clients that is determining, what size blocks people are able to produce.
Gotcha.
I mean, and look, currently, I mean, Frankendancer doesn't have 20% at stake. So if we did this, people could produce blocks that Frankendancer couldn't replay, and the network would keep humming. But I because of how we built Frankendancer, we wouldn't be this lower client today, but it certainly could flip in future.
Mm-hmm. And then I want to close by asking maybe a more philosophical almost question, but something I think about from time to time is, say blockchains really catch on and these are the financial rails of the future. Is the final form of a blockchain going to look like Solana or something very similar to it? Or is there untested design space that can go even further, basically? So I kind of want to ask you, as someone who came from outside the Solana world and now is trying to push the limits of what this blockchain is capable of, like, do you think that Solana is the final form for what a blockchain can be? Or maybe, like, if that's too heavy of a question, just like give me kind of your review as like an outsider who's become an insider on how this thing functions.
Such a good question. I think my immediate response is no. If you look at what even Solana was in 2020 in the white paper, it looks nothing like it today, right? And I imagine 4 years from now, 5 years from now, it's probably not going to look much like it is right now. That is why Solana does so well, is it's an evolving project that is kind of constantly, keeping pace with the ecosystem and the needs of the users. I mean, Alpenglow is a good example of what other blockchain would go and redesign their entire consensus mechanism from scratch and try ship it in 6 months, right? That's undoubtedly a good thing. So I would say, if there was a platonic ideal of a blockchain and God floated down, and gave us some GitHub repository that it was, I don't think it would probably look much like Solana. But at the same time, there would be concepts that are very similar. And you can look at Solana and see really, really amazing pieces of technology in there. Turbine is a really good example. The way that blocks get propagated through the network is actually it's held up the test of time. It's going to be there in Alpenglow. It's almost that almost is the platonic ideal of block distribution. There are other parts of the protocol that are probably not. I mean, some of the programs that users invoke to do things to stake a validator. I mean, the stake program is this incredibly complicated, tens of thousands of lines of code. That probably is not a platonic ideal. And there's things that are in between. So I think Solana, it has the trappings of it. It has the potential. And I think the trick is over time, can you adjust to keep becoming more and more like it? Or do you get stuck, kind of doing 7 TPS or whatever? I think that's something Solana's doing really, really well. So it'll continue to evolve towards it, perhaps.
Mm-hmm. And I know I said that was the last question, but we don't have Firedancer folks on often. So I guess I'll just say, is there anything else you want to say? There's been a wide-ranging conversation. Is there stuff we haven't covered that you think is important for people interested in Solana to know? Just anything any bases we haven't hit yet.
I think I'd kind of just maybe try gather a bit of sympathy for like the project, and there's a ton of excitement for Firedancer. So we also hear a lot like, why haven't these guys shipped? What are they doing? Where are they at? And I would speak to the engineers that are listening. It's like, well, have you ever tried to rewrite a code base, right? And let's say in the abstract you have a 2 million lines of code base, and your boss comes to you and says, hey, we're gonna take all this and start over. You would just be like, no way, like not happening. Like those projects have never succeeded. Like in the history of engineering, no one has really been able to rewrite code bases like that. But you kind of want to take a flyer and you say, oh, okay, like let's try it. And then your boss goes, okay, but like you're going to do this with a completely new team. So a bunch of people that don't know this problem space that well, and you're just going to like learn it from scratch. And by the way, the existing team isn't going away. They're in fact, twice your size, and they're going to keep building the existing thing. And they're going to keep like making improvements to it. And I would say like it's nuts, right? Like it's kind of a crazy thing to even attempt. And the fact that we're doing it and we've shipped, and like the product is alive and is like gonna deliver is, I think, pretty impressive. And not something that people kind of recognize, like the amount of like difficulty and engineering investment and like challenge that is involved in that. So that's kind of the one thing I would really highlight.
Mm-hmm. Yeah, and I think this episode is dove into where those challenges stem from in some pretty interesting ways that were new to me, even as someone who follows this stuff. But yeah, Michael, thank you so much for taking the time to speak with me. It's been a really fun episode.
Yeah, awesome. Thank you for having me on. That was fun.
Thank you, everyone. If you've made it this far, we would really appreciate if you give us a like, a 5-star, wherever you get your podcasts. If you enjoyed this episode, please share Lightspeed with a friend, and we will see you all again very, very soon.